For this problem, we're going to analyze the graph of a quadratic function. For the quadratic function f of x equals 3x squared minus 12x plus 4, we want to determine whether the graph opens up or down, determine the vertex, determine the axis of symmetry, determine the intercepts, and then use the information from the first four parts to sketch a graph of the function. Start with part A. We're going to determine whether the graph opens up or down. To do that, we look at our leading coefficient, that is the coefficient on x squared. Since our leading coefficient is 3, we have a is greater than 0. Because we have a positive leading coefficient, we know that the graph opens up. On to part B, we want to determine the vertex. To find the vertex, we need to first identify the coefficients of our quadratic function. We have a is equal to 3, b is equal to negative 12, c is equal to 4. The x-coordinate of the vertex is given by x equals negative b over 2a. So we'll have negative 12 over 2 times 3, which will give us a positive 2. We can find the y-coordinate of the vertex by plugging in x equal to 2 into our function. That is, we find f of 2. That's 3 times 2 squared minus 12 times 2 plus 4. 2 squared is 4. 4 times 3 is 12. 12 times 2 is 24. 12 minus 24 is negative 12. And negative 12 plus 4 gives us negative 8. So the vertex is 2, negative 8. For part C, we're looking for the axis of symmetry. The axis of symmetry is a vertical line that passes through the vertex, and so it has the equation x equals negative b over 2a, which is just the x-coordinate of the vertex. Therefore, the axis of symmetry is x equal to 2. Next, we're going to find the intercepts. Remember, there are two types of intercepts we need to find, x-intercepts and the y-intercept. We'll start by finding the y-intercept. To find our y-intercept, we're going to let x equal 0 and find the value for y. It means we need to evaluate the function when x is 0. So we find f of 0 is 3 times 0 squared minus 12 times 0 plus 4, which is just equal to 4. This is the constant term in our quadratic function. To find the x-intercepts, we're solving f of x equals 0. Remember that x-intercepts are the same as zeros for our function. That means we need 3x squared minus 12x plus 4 equal to 0. This is a quadratic equation. You could try to solve this by factoring, but factoring won't help us in this case since this does not factor nicely. So we're going to rely on our quadratic formula. We have a is equal to 3, b is equal to negative 12, and c is equal to 4. Plug these values into our quadratic formula. We'll have x is equal to negative 12 plus or minus the square root of negative 12 squared minus 4 times 3 times 4, all divided by 2 times 3. Clean that up a little bit. We'll have x is equal to 12 plus or minus the square root of 96, all divided by 6. We can simplify this radical a little bit. End up with x is equal to 12 plus or minus 4 root 6, all divided by 6. If we cancel out a common factor of 2 in the numerator and denominator, we'll have x is equal to 6 plus or minus 2 times the square root of 6, all divided by 3. So our x-intercepts, the x is 6 minus 2 times the square root of 6 over 3, which is approximately 0.37. And we'll have x is equal to 6 plus 2 times the square root of 6 over 3, which is approximately 3.63. Now we can take the information we've obtained in parts A through D to sketch a rough graph of our function. We're going to start by plotting the points that we know. We found the vertex to be the point 2, negative 8. So we'll plot that point, 2, negative 8. We found the y-intercept to be at 4. We'll plot that point. It's the point 0, 4. And we found two x-intercepts. We're going to use the decimal approximations here. We found one of our x-intercepts to be roughly 0.37. That puts us right around there. So that'd be 0.37, 0. And the other x-intercept was roughly 3.63. Put us right about there. Call that 3.63, 0. We're going to go ahead and just connect those dots. Curve. And there we have a rough graph of our function f of x.